Good morning all. Let us start the topic of today, that is triangles. I would like to start this topic with a famous saying on the topic triangles: be congruent, be authentic, be yourself. So with this positive note, let us begin our chapter. In this chapter, I had made a lecture plan for next 15 minutes. I will divide my lecture with the introduction on triangles. With the classifications, I will be considering side and angles for classifying triangles. For each classification, I will be having 3 different categories of triangles that we are going to discuss in this chapter. Then what is the term congruence mean, that we are going to introduce in this chapter. The next few criterias which will have SSS, SAS, AAS, ASA and RHS, where S stands for side, A stands for angle. With this note and a short lecture plan, let us begin our topic, triangles. And with this, we will going to introduce our 2 set squares, which will be the geometrical figure. We are going to use these 2 in the lecture as well. Now you will be thinking, what is the use of these 2 set squares? They have multiple use in engineering drawing, plus in your 10th, 12th, they will be helping us to draw a parallel line. Let me show you how. See, you can keep a pen, you can keep one ruler like this, and what you can do, you have to just slide your set square over the ruler to get 2 parallel lines or a number of parallel lines, as many as you want. Let me draw one parallel line for you. This is my original line. If I want to draw another line, I will be just sliding my set square over the ruler, and see, this way I can draw a number of parallel lines on this with the help of these set squares. So this is one of the important rule of using set square, the applications. Now why they call the set square? See, they are from the geometry set, which is having protector, set squares, rulers, rounders, dividers. One of them is set square of these 2 categories. Now I will ask you, we are going to characterize these 2 set squares in these classification. In the later of the lecture series, in this lecture you will get to know what is isosceles triangle and what are scalene triangles. So this is the example of isosceles. In the lecture I will also explain this, and this is the example of scalene triangle. Now let me show you one more term of getting how another application of using set square. So for that I will be using 2 small set squares for getting the radius of a circle. Let me show you how. Now let me show you how the next application goes with the set square. See, this is my circle. I want to measure the diameter of the circle. For this, what I will do, I will keep it and then I will keep a ruler below it, and see how I am going to measure the diameter of the circle. So this is another important point of using set squares. So let us now begin introduction to triangles. First of all, I am going to give you the introduction on the topic triangles. Triangle is basically a closed shape with 3 sides, as you can see in the diagram. Now, triangles can be classified in 2 ways. First, considering the sides, and another considering their angles. So if we are considering by sides, they can be classified into 3 parts. First one is equilateral triangles, second one is isosceles triangles, and the third one is the scalene triangles. The respective diagrams for each kind of triangles are drawn here. As you can see, in the very first triangle, all 3 sides are equal. In the isosceles triangle, you can see the 2 sides are equal and one with a different side. In the scalene triangle, you can see that we are having all three sides which are different to each other. Now with this, I can show you few examples of scalene and isosceles triangles. Now we can also classify the triangles as per acute angle triangle, right angle triangle and obtuse angle triangle. In acute angle triangle, you can see that all the angles are acute angle. In right angle triangle, it is one of the angle is 90 degree. In obtuse angle, you can see 120 degrees, which is more than 90 degree, and it is obtuse angle. So you can see that we have classified triangles in three categories. Now comes the topic congruence. What do you understand by the word congruence? Congruence means equal figure whose shape and size both are same. The shape as well as the size both should be same. See, if the first triangle is drawn with 4 cm, 5 cm and 5.5 cm as the sides length, the second triangle is also drawn with the same sides, and even you can check that they are of the same shape. They both are representing triangles. Now the sign of congruency is equal to with a curve over the head. Let us now name the triangles A, B and C, P, Q and R. We can write with the symbol of triangle ABC is congruent to triangle PQR. Now as for this, I had drawn two triangles. I have made two triangles, and these two triangles will be called congruent. As you can see even in the figure, these two triangles will be called congruent only if they overlap with each other. The very good example for congruent triangles are the overlapping of the two triangles. That is, they are having the same shape and they are having respective sides which are exactly same. So this is the perfect example of congruent triangles which is overlapping. Now let us discuss some of the criteria of congruence of a triangle. If I will discuss the criteria of congruence of a triangle, they can be classified in 5 different categories. The first one being SAS, side angle side, triple S, side side side, ASA, angle side angle, and AAS, that is angle angle side, RHS is right angled hypotenuse side. As you can see, S stands for side and A stands for angle, as we have discussed in the beginning of the lecture. Let us now come to the first congruency rule, that is SAS, side angle side. When we are discussing this side angle side, one side should be same as the another side of the triangle. One included angle should be same. That is, in this case it is angle ABC and angle PQR, and another side, that is side BC and PQ should BC and QR should exactly be same. So PQ is same as AB, BC is same as QR, represented by double cuts, and the single cut represents that these corresponding sides are same. Similarly, for triple S, we should have all three sides of the triangle same. As you can see, AB is equal to PQ, BC is equal to QR, and AC is equal to PR. Okay, so these are the two congruency rules, and we can say with this we can prove that triangle ABC is congruent to triangle PQR. Similarly, the third criteria is angle side angle. We can prove it that two angles with the included side, when they are same, the two triangles are congruent. And for this, we can have various examples, and theorems are based on these criteria. We have to prove them using different conditions. So let us prove that ASA, SAS, triple S and RHS, they are some congruency rules that we are going to study in this chapter. Similarly, the fourth one is AAS, two angles with one side. As you can see, angle A is equal to angle P, angle B is equal to angle Q, and AC is equal to angle. This side AC is equal to this side PR. That is AAS. So this is satisfying this congruency condition, And with this we can say that triangle ABC is congruent to triangle PQR. Last property is RHS, that is right angle hypotenuse side. R stands for right angle, X stands for hypotenuse, and S stands for the side. The right angle, that is angle ABC, should be equal to the right angle of another triangle, angle PQR. The hypotenuse is AC for the first triangle and hypotenuse is PR for the second triangle. That should be same, and any one side should be same. So with this criteria we can also prove that the two triangles are congruent. Okay students, now let us discuss some of the things which are not given in the textbooks. So I'm winding my lecture with these 2-3 points which are very important conceptually to understand the topic of congruency. If somebody will ask you the practical example of congruent figures, you can give the example of your hand. See, your hand is perfectly congruent. Your two hands are perfectly congruent to each other. See, the rule of congruency includes you can flip the object, you can turn the object, you can slide the object. These facilities are available with us. So, these two hands which are given to us are the best example of congruent figures. So, I think with this example, I have made the point very easy how the congruent figures look like. Similarly, if I want to make these two triangles, I can flip it, I can fold it, but I cannot fold it. I cannot have the fold should be in both the directions. But yes, we can flip it, we can slide it. What does this triangle represent? You can categorize it in isosceles triangle considering the sides. These two sides are equal and this is the longer one. Similarly, this triangle can be categorized as the skilling triangle considering the sides. This side and this side, they all are different. So it's a skilling triangle. Now let us consider the angles. Can you give me which category this triangle falls? This triangle falls, as you can see, all the angles are acute angle. You can see this. And this angle, these two angles are acute angles and this angle is 90 degree. So I will categorize this kind of triangle in the right angle triangle. Similarly, I will ask for this. This again, you can see these two angles are acute angle. But what about this? This is my 90 degree angle. So again, this set square is again in the category of the right angle triangle. Now you can see these set square, the another name given to these set square is T. See, they are forming T, isn't it? So with this interesting note, I would like to say thank you to all for attending my lecture. We will try to meet soon. Thank you.